Yes, so first part of class today, there was internet issues, saying this for the video now. The people here are well aware of that. During the break, I checked and the router's fine as far as my MacBook and Chromebook are concerned. So it has to be this, my Windows machine that's the one I use most often. That's my go-to machine. So it has been heavily used for 3 years, and perhaps the card's wearing out or something. Maybe there's something else going on. I'll check more thoroughly later when not in the middle of something, because it only started a couple minutes before class. So hopefully it's gonna work for this next part. But well, we saw before the break how to put together, how to draw on the screen from code, draw rectangles, draw circles, put words up there. The stuff we'll need for the heads-up display, which is something we'll want in every game, provide the user information. And right now we're working in Python. Later in the semester, we'll be working in C#, which means we need to do a pass at the basic syntax for those languages. So it seemed good to combine the two and the two birds with one stone thing. So now let's use that the UI components, which obviously a video game is a user interface or UI itself. So when we say UI about a video game, we're usually referring to the HUD, the heads-up display sort of stuff. And we'll just use that for the output on the passive Python syntax instead of the normal console stuff. Because I always feel like consoles are kind of outdated. I'm old enough to remember when graphical user interfaces kind of took over. Back when we switched from having to do everything in a prompt or a terminal to being able to click buttons with our mouse. And when that happened, I thought I was done with the consoles and terminals, but I guess that wasn't quite the case. So we'll look at the syntax here for the Python programming language. So let's see, I'll make a note here. Python syntax. And I'll put all of that here. And whenever we go to output something, we have this variable called output. So from the basic Python syntax examples, I will just initialize that as a string. And whatever result we get from the simple stripped down examples here, we will put into that string, and it's already set up to print that string onto the game user interface. I guess we can call it that. The rectangle with green rectangle with gray text on it that we set up before the break. So everybody in here should have at least had the SDEV 120 class, right? I know a couple of y'all just had that with me a couple weeks ago. Some people had it with me previous semesters. But everybody's seen that basic intro to logic, right? The components we have to work with. For problem solving, there are 4 tools we need to solve a problem. We need some sort of sequential tool, an order for things to go in, and that's defined in our programming language itself. When we put our code together, there's a certain order we have to put it in order to translate into something the machine knows about, which didn't really show up today so much, but I would like to point out that that order probably isn't the order we think about it in. So it can be a lot more productive to jump around your text file in the order you think about it in, and just the final result has to be in that order for the computer. But if you jump back and forth, things will flow the way you think about them. The coding will come together a lot more fluidly and seem more efficient, I guess. So there's that. We also need a way to make choices, selection structure, selections, different pathways we can take, branch off from our sequence. That's necessary for any type of problem solving. A way to reiterate things, repeat steps as needed, usually with a little bit of variance. I like the example of mowing a yard like a push mower, because exact repetition, that's the same thing. Right? Mowing with a push mower, that's like mowing a strip, going back and mowing that same strip again, over and over and over again. We'd never finish mowing our yard. So we need a little bit of variance in there. We mow a strip, turn around, move over, and mow the next strip. And that way the yard eventually gets finished mowing, but the main step there is just mow a strip of the yard. That gets repeated over and over again. So we need some sort of reiterative structure to solve problems. And then the fourth of the ones that's absolutely necessary is often referred to as invocation. We need a way to jump out of our sequence, do some other stuff, and come back to where we were in the sequence. From programming languages, that usually refers to like methods, where we have a pre-built segment of code that we can just go ask for at any point, leave our current sequence, do those steps, and then come back to where we were. Reiterative structures, machines have recursion, which is controlled feedback loops. Output goes to input, gets processed, then once again, output goes to input and creates a feedback loop. It's really, really hard to work with and can be a little bit tricky, and sometimes we have to make big adjustments to work with it. So most of our programming languages have a simplified structure called loops to handle repetitive things. And loops are based off the same way we put together our selection structures, which are usually if-else structures, where our keyword is almost always if, but when putting the code together, I like to say, think about the word is. We're asking a question. If we have some value stored in a variable called x, we'll ask, is x bigger than 5? And if so, do this stuff, but if not, do some other stuff. Hopefully you all saw all that in the SDEV 120 class, or whichever one you've seen. And that's the tools we have to work with, the most basic ones. So we learn those, and the syntax for them is different in all the programming languages. So once we know how to learn how to use one, then to program in a different language, all we need is that syntax. And SDEV 120 class covers it in detail. And a couple of people in here are in my 6 o'clock class tonight, the SDEV 140 class, where we do once again, cover it in detail. So what we're getting ready to do in about 30 minutes here is what we're going to do is for the next 5 or 6 weeks in SDEV 140. So it's very detailed, and then we can just see the syntax for the language and start to work with it, because we know how to use those tools for problem solving. And the first one is a sequential tool, the sequence, the order things go in. So in Python, it's open. It's an open type language. We don't have to say we have what type of data we have. We can just start with a variable. If you use like the C family of languages before, if we're going to have an integer, we have to explicitly say we want an integer, call it this, and then assign it that. But Python's open typed, so we don't have to say what type it is. We don't have to say we have an integer. We just set up a variable and then assign it some value, maybe 34. So one equal sign is used for assignment in Python. And typically it's kind of like we read things right to left. So this is another point with that out of order thing. I'll come down here and put a couple lines. If I said I equals 1, and then I equals I plus 1, those lines of code work, right? We know we'll put a 1 in this value, and then on the next instruction, we'll increase it by 1. That sort of thing usually goes in the loop. But there's an indication here, you can kind of see that we do this part first, because we use the old value of I. So we'll do this part first, which means when the computer processes this code, even though we typed it left to right, and would probably read it left to right, I is assigned the previous value of I plus 1 more. The computer does this part first. So the computer is actually working right to left on this instruction. So by the time these things get translated into machine language, it may be quite different than what we type in our code. Just some things to keep in mind. Really for debugging, that's the thoughts for when things don't work right and you have to track down problems. But for when things work right, we just say we have a variable. I'm going to stick the number 34 in it. I'm going to add a number there too. So my number 1, then I can do my number 2 equals maybe 27. So a couple of integers to work with. That way we can see some math stuff to start with. Our sequence is just the order we go in. Line 1 will run first, and then line 2, line 3, and it just goes in order of line numbers, top to bottom. That's our sequence. So we'll do some assignments, and then we can do some math with it. I'll make a variable called res for result. You'll often see that in reference material. So whenever you see res used as a variable in reference material, it's an abbreviation for result. Then we can do math with those. My number 1, we'll start with adding, plus my number 2. And that'll just the variable plus sign to add those numbers together. Well, I said it's open typed, right? We didn't have to say that we're going to store an integer. We just said we have a variable, we stuck an integer in there. But once we do that, then Python will look at that data we put in it and figure out what type of data it is. So we didn't say it's an integer, but at this point, we added 2 integers together and stuck them here. So Python does know it's an integer. So if we tried to say output equals result, I'll go ahead and throw the error, and then we'll come back and fix this. Then down here, when we go to put that on the screen, we said we have a string because we turned it into text. We turned it into written text. So we're saying it's a string down there, but up here, we just put an integer there. So even though we don't have to say what type it is, we will have to cast it. So we'll get an error like this. I like to look at error messages and talk about how to deal with them. So again, the file it's in, looks like line 42 had a problem. Text must be Unicode or byte. So if we take the information from that error message, go find line 42. So, oh, this is the text we want. And it's saying must be Unicode or raw byte data. And well, we put an integer there. So we need to convert that to Unicode values. And our term for that is casting. So to cast objects is sort of a pre-built method. And notice that a little predictive thing came up, string. It turns some sort of object into a string. We need to turn that object into a string. So in Python, it's just str. If we need to have a string and want to turn it into an integer, we just type int or fl or float if we want a floating point number. But in general, our casting is built into a method like this. String, int, float, whatever we're going to turn it into. And then as an argument, so inside of the parentheses, we pass in the thing we want to change the type of. So that should give us something on the screen. If I come over here and rerun that line, that time it worked. Added those 2 numbers together, gave us 61. And instead of the console, just outputting it directly to the graphics window. Whoops, I don't want to click that. Click that. There we go. So we have lots of math we can do. Basic math. We can multiply, obviously subtract them. I'll just run each one of these one at a time. Subtract them, multiply and divide, an asterisk for multiply, 1 asterisk for multiply. That'll be important in a second. Get the product of them. Then we have several things we can do in division. Well, if we divide it, what happens when we divide 2 numbers? It might come out evenly. It may not be even, right? You could have that remainder, or which we often display as a decimal. So if we use 1 slash for division, that gives us floating point division. So that gets us the quotient, and then the remainder is converted into a decimal fraction. That's the technical term for the dot, digit, all the stuff after the decimal point and the way we normally write numbers. So floating point division is 1 slash. I'll come over here and run that. When we divide those numbers, see we get 1.259. We get that fractional part represented as a decimal. But maybe that's not what we want. Maybe we just want the whole number part. So if we do 2 slashes, that'll give us integer division. So 2 slashes gives us the quotient and throws away the remainder. So what numbers did I put in there? So if we take 34 and divide by 27, well, 27 will only go in there 1 time, and then we have what? 7 left out with a remainder of 7. So if we do integer division, then we only get that first digit. We get that 1, and then our quotient is disregarded. And we can get the quotient from modulus, which will be a percent sign. So my number 1 mod my number 2. That means we're going to divide, but we only want the remainder. There are a lot of shortcuts in math. When it's modulus, we actually call it a residue, not a remainder. If the remainder is the part we want, it's called a residue or residual number. That's a little technicality, but most people are probably familiar with the word remainder. So when the remainder is the one we want, we can do the modulus operation and get that 7, because remember, 34 divided by 27 goes 1 time, and we have a 7 left over that wouldn't fit evenly. So different ways we can get the division stuff. Our basic operation is exponents, and there's 2 ways we can do it. In some reference material, you'll see a caret used for an exponent, and that is actually just something that happens. A caret is our operation for XOR, the exclusive OR operation. So it just so happens that if we have binary numbers, the XOR operation returns, and we do an XOR operation on binary numbers, we get an exponent. The actual one for it, set up in the Python language, is 2 asterisks. It's kind of like multiply, multiply, is how I would always thought of that. So that's our actual symbol for exponent. So 2 asterisks will take 34 raised to the 27th power. So some big, huge thing. Yeah, that great, big, huge number. But 2 asterisks is for an exponent. That's our basic math. We can do some other stuff. What's one that's here? I'm gonna take that off, and I'm gonna make the 34 negative, because then I can do another thing that's built in is we can take the absolute value of a number. How far away from 0 the number is, which always is positive. So that's often just described as we turn a negative number into a positive version. With absolute values built in. Then other things, there's some other ones built in, but trying to go kind of quick here. Maybe we want to take the square root. That's a very common thing to do, right? With the square root of, well, I'm going to get rid of that negative sign now. The square root of 34. When I go try to run this, though, it doesn't like it. It crashed. That's because line 20, a name error. That means it didn't recognize something. And what it didn't recognize is square root is not defined. So a lot of our math operations are in an external library that we have to build in, or we have to import. We have to bring it. It's already built. We don't have to build it. So up at the top, we can import the math library. And there are a whole lot of things built in there. So we can say like math.square root. So in the math library, there is a method called square root. So we have to get it from there, some of our more advanced ones. There's the square root of 34, a little bit less than 6, kind of what we would expect from it. And there's lots of them in there. Again, it's something that you want to look them up as needed. Once again, always remember to check official documentation first, or other things. One of our trigonometry functions, which probably should have shown up in the vector discussion, but hopefully we can omit that and treat it like a calculator button. But the cosine of some angle, so the cosine of 34 degrees is this number. I guess that's the cosine of 34 radians. But the cosine of some angle. And we have different ones. I'll leave the square root up there for when I send out the notes later. But basic math, that's our starting point, right? Computers and machines can do math, so we'll have to do a lot of calculations, especially in game development, right? If the enemy lands a punch on our character, or some mob lands a punch on our character, our hit points go down, or vice versa. If we find a treasure chest, our resources go up. So there's a lot of math in it. So we'll need to do a lot of math things like that. And then that's the stuff you want to represent by like the size of the rectangle and the words written on the heads-up display. So that's something to practice later. I'll just make a note here for basic variables. That is basic variables. Really straightforward. We don't have to do anything special in Python, and we can change that. We don't have to say what type it is. We can put something else there later. All we have to do is say we have a variable. So this is that point I made just a moment ago. Lots of small steps is often better than one big step. So if you have a big long string you want to build up, we can concatenate it together. I'm going to do an extreme example here. So this is kind of redundant. O plus cast as a string, line number 1, just because we have something there, and that way it's not quite so redundant. Plus a space, plus cast as a string, line number 2, plus world. And there's a big long string. Concatenation to put two pieces of text together to make a bigger string is going to be the plus sign. So those can sometimes get to be a mess. That'll work. It builds up a string here. I'll come over here and run that. You can see hello world with a space, and then I just do the numbers in there and get rid of them on the next step. But an alternative is to spread that out over several lines. So I'm just going to do it in a couple things. So we're adjusting our output. First thing I'm going to do is make it an empty string. So I'm going to start with an empty string. And then on the next line, I'll add something to it. So I'll write it all out at first. I'll put whatever was there plus the word hello. But this happens a lot, right? It's instead of just assignment, it's like reassignment. We're going to take the value that was already in that variable and add something else to it, and then stick it back in the same storage location in RAM. That happens so much that most of our programming languages have an abbreviation for it. They're called assignment operators. So in this case, the concatenation assignment and we put both operators together. So concatenate assignment by hello. And that works with all of our math too. So add, subtract, multiply, divide, modulus. We can apply that as just one single assignment operator instead of writing the same variable on both sides of the equal sign. And then add that word to our empty string and output concatenate assignment with a space and output concatenate assignment with the words world. So sort of an overly trivial example. That would have been nothing in one line, but the point there is to build up a string. Lots of small steps, because when you need to do this in your code, it'll be a little bit more complicated and look like a complete mess if you try to do it in one line. If you spread it out over several lines, it's a lot easier to debug. If something goes wrong, it's a lot easier to find the problem and fix it. And you can stretch it out into lots of small steps instead of one big step. It's just kind of a tip there, but I guess I'll run it. I'm going to print the words hello world on the screen. Yeah. But just the tip is stretch the instructions out over multiple lines if you can. Think of ones and zeros. A machine either does something or it doesn't do something. So lots of small somethings is better than one big complicated something up on our end. And variables aren't the only place we can store stuff. We can also put things in lists and keep collections of numbers. Oh, indenting is important in Python. Notice that all these, well, I'll throw an error here. So I'll throw an error. So I'm going to create a list, and there is a problem here. Python is object-oriented interpreted language with significant white space. That means our white space matters, and what I just did here is going to be a problem. But let's look at the error message that throws, so you know how to detect when that happens. We can put together a whole collection of things, and we saw we've been using tuples for our vectors. The parentheses with a comma separated list in between it, like we did on the colors, so like 12, 12, 12, a very, very dark gray. That's an immutable list. That means we put the values in as a collection, so they stay together. We're going to refer to it this way, so we can ask for them one at a time. But with a tuple, we can't change them. If we need different values there, we'd have to put a different tuple in there that had different values. So they're immutable. It helps to prevent accidents from happening. More often, we use square brackets for our list, which is a collection that we can go in and change. We put a bunch of things here. So like 22, hello world, true, green. Just put a bunch of values there. And then I'll say output is this output variable that's already going to the screen. I'll ask for my list. And then we need an index to ask for one of the things on the list. And Python starts counting at 0 because we ask for the beginning of the data. Right? We ask for where that data starts. So that's where the computer's going to look in RAM. It's going to go, but we don't count it till the end of the data. Right? So 22, that would fit in a 1-byte integer. So we're going to ask for 0, the starting point of the list, but we don't actually count to 1 until we get past that first item in the list. So ask for the beginning, count from the end. And Python's one of the languages that starts at 0. So if we want that 22, we'd put in a 0. If I come over here and run this, oh, that error, I almost forgot about that. Then we see this, which has to do with the significant white space in Python. Unexpected indent. It did not expect to hit this indentation here. So since haven't blocked out code yet, that's the next thing to talk about. We do have to put your code all the way over at the left and watch spaces. Hitting the tab key to get a wide space and hitting the space bar 4 times is not the same thing, and it will throw an indentation error. So you do have to be consistent. You can use either one, but you can't use them both in the same script. Now if I come run this, oh, that's right. Index 0 is a string, so we have to cast that. Or it's an integer, so we have to cast it into a string in order to print it on the screen. And there we go. That gives us the first item in that list. Or the index 1 is the second item. Index 2 is our third item of just a comma separated list. So if we want the fourth item, we'd ask for index 3, which is already a string, but it doesn't hurt to cast a string into a string. Computers don't mind redundancies. And that gets the fourth item in the list, which starting out into programming, it's hard to see the advantages of working with lists and arrays and things. It does pay off in the long run. But when we're first starting to program, the examples are small enough that it doesn't seem beneficial, but it really is. You can think of it like a backpack. Right? If you go to the campus, head up to school, you could carry all your books and your pens and your calculators and notebooks, just carry them as a stack and grab items one at a time. That's kind of what variables are. Or you could put them all in one backpack, put all of your school supplies in a collection, and then whenever you get to school and need something, you dig through that backpack and pull it out. Lists are kind of like that, but it's hard to see when we first get started programming because when we're first starting to program, examples are small and easy. So there's one other thing when we talk about it with lists, but I'm going to come back to that in a moment. But that's how we bundle data together to use it. So in game situations, your player is going to have a lot of data about them, right? Like they're probably going to have a name, true or false, like wearing armor or wearing fabric. True means they have armor. False means they have robes for maybe some fantasy sort of game. Some sort of number to represent what they have to trade with when they get to town, right? A number of gold pieces, and then a number of hit points and experience points, and all of that stuff works really nice in a list. Then anything about your player, you can just grab that index off the list and keep everything about a certain player, all the stuff about the player, the NPCs, the mobs, and all of it gets collected into a single list that we can use that has all the data about that player or that NPC or whatever it is in question, whatever the thing in question is. So it gives us that might be a nice way to think about lists and make sense of how they're useful. Because once again, it's kind of hard to see at the introduction level. The next thing is choices, right? Selections. We need to branch off of our sequence. We might need to make different choices along the way. I'm going to set up some variable here. I'll just put in a 27 to start with, because we're just looking at the basic syntax. We need a way to make a choice. We want to do different things depending on the value stored in X here. And our keyword, so we're going to ask a question. We're going to ask, is X less than 27? That's not the right syntax. That just happens to be a keyword as well. That's what we want to know, but we're not asking the computer to do something. We're telling the computer to do something, right? So our keyword is if. So if X is less than 27, then we need a colon, and this is where we end it. everything that we want to happen, if this condition is true, it's indented. I don't know, I'll say output is assigned the string, that's a small number. And then there could be multiple lines there. Whatever we want to happen when this condition is true gets indented. And then when we're done with that, we undo the indenting, unindent for the next part. And well, obviously there's a true or a false, right? If and otherwise, which our keyword for that's going to be else, but we can combine them too. So if this is true, well, if that's not true, then we can check something else. We don't have to do just one or the other. We can build things up. So else if is very common, except that in Python, we have significant white space. So having two words, so if that's not true, then check this condition is a problem. So that's abbreviated in Python to ELIF. Just ELIF for else if. So if X is, if it's not less, I'm going to put a 50 there, just some range. If X is less than 50, we'll do this stuff. But if it's not, well, then let's do another condition. Let's check and see if it's less than 100. Then if that's the case, we'll put a medium-sized number. A rather trivial example, but hopefully the syntax is making sense. So if, elif, and then we can keep adding elifs, else ifs, and checking more and more conditions till we get all the way through, check every possibility. And eventually, we want to make sure there's a default case where we don't have a condition. That's just like, if nothing else there was true, what are we going to do? In that case, output equals, so here it could be a small number, a medium-sized number, or a big number. That's a big number. And that's our general syntax for the if-else structure. Any questions about that? Right. And we don't need the whole thing every time, and every single situation is going to look a little different on those. Because maybe we only have one thing to check. We're either going to do this or not. So then we'll only have the if. Or maybe it's a one or the other. In that case, we'll have the if and the else, and we won't have any else ifs in between. Or we might have the if at the top, the else for the default way down at the bottom, and we might have 50 or 60 different things we want to check in between. Right? There's a lot of things that could happen in a game. A lot of things we might need to check. So that's our syntax, and that's the general form Python takes. We have a keyword, something that relates to our specific instance about that, what we want that keyword to do. And we're going to see other keywords here in just a moment. Then a colon, and then all the pertinent parts get indented afterwards. So if X is 27, I run that. Wait, why does that still say green? Oh, whoops. Have to spell output correctly. Just notice that time it didn't even throw an error. A typo in a variable name, it just stored that variable and then went on with some other stuff. So it didn't even throw an error. So sometimes tracking down problems is a little harder. Okay, so yeah, it's less than 50. Our first condition was met, so we went in here and said it's a small number. If instead of 27, it was 72. Save that and come over and rerun it. It's a medium-sized number. For 127, we'll hit that third condition. So that way we can set up different things that happen each time and set up different conditions, which are very situational. But if that makes sense, move on to the next little part. I'll put a label here, selection structures. So that's our basic one, and we kind of piece them together for our situation. The next thing I mentioned on those tools we need, the sequence, the selection structure, we need a way to repeat things, to reiterate things, usually with varieties, with some sort of variety. And well, we saw a while loop, but I'll go ahead and include that. That's the main one we're going to use. Counter is 0. I'll start a counter at 0. While that counter is less than, say, 8, we're going to do stuff. Say output plus equals. Actually, I'm going to come back up a couple lines. So this is that jumping around thing I was talking about. I need output to be empty, so I can just add it. I can just write out whatever the counter is. So I'm going to jump back up a couple lines and reset output to an empty string. And then each time through, we'll concatenate assignment. So reassign output, whatever output was, concatenated with the counter cast into a string and maybe a comma and a space. That way they're separated out. Anything else I need to do on this one? Anybody notice anything missing? If I come over here and run that, what's going to happen? What's happening here? Anybody have thoughts? Should I try to close it? That's a problem too, right? Yeah. Mark pointed out in the chat room, we entered an infinite loop. So it kind of caught it. If you're running from a terminal, you can push Control-C to cancel out whatever's going on. That cancels your current instruction on the terminal. So if you enter an infinite loop, make sure and do that. And in a while loop, you want to remember to increment counter. So here it's addition assignment. So we're going to reassign the variable counter by taking whatever was there and adding one more to it. So that way it does eventually reach 8 and finish our loop. So watch out for infinite loops, but we have ways to stop those if necessary. If you're in a normal development environment, there's probably a stop button. But if you're running in a terminal or prompt of some sorts or shell, Control-C usually cancels whatever instruction got stuck. So you can see it loop through. It just kept repeating that instruction of printing out whatever value is in the counter and then incrementing the counter until it hit our condition. So that happens as long as it's true. I'm going to scroll up a little for the next thing on loops. So in Python, we actually have what are referred to as for each loops in most of our other languages because they go with things. For example, this list has a bunch of things in it. We can do a for each loop and loop for each item in that list. So that's what our for loop is in Python. I can say like for item in my list, and there's a finite number of items here, a countable number of items. So we're just going to go through one at a time. We'll call it item. We'll call the thing item, and then we'll I guess just print that out. Do the same thing. Output plus equals cast as a string, whatever item is. And here we don't have to worry about counting or anything because there's a finite list. I'm going to cut that and put that down here at the bottom so that it overrides the whatever was an output there. I guess once again, I probably want to reset output before doing that. So output gets set to a blank string. Then we're going to loop through that list of items we have, turn each one to a string, add it to that, and maybe a comma in there to make them, comma in a space to make them look a little bit nicer. So kind of the same thing, but it's like for each thing that we put in my list. I run that. You can see all the items in the list. I guess the output was semi-trivial there. You all knew what was in the list. And notice that thing I pointed out up here. We have a keyword for the Python language. And we have something specific for our situation. And then a colon. And then a bunch of indented code. That same general structure we saw with our if else. Same thing here. We have this keyword, something specific to our situation, which in this case involved another keyword itself. The keyword, something specific for our situation, a colon, and then we indent things. That's what I always think of as just the basic Python syntax, because a lot of things follow that. The next, any questions about loops? We can also count in for loops. I'll do that here for I and this didn't show up until like Python 3, 4 or something. So for I started using Python around 2006, 2007. I remember which computer I had, but I can't remember exactly what year it was. Around 2006, 2007 is when I first started learning Python, and it wasn't. And this didn't show up until several versions of Python later. So like the first 13 years or so that I used Python, this wasn't available, but it is now, and it's very useful. We have this function called range that's what we can see in the prediction thing here. This range wants a start value. A stop value is the only one required. We have to say like 20, and then it'll go all the numbers from 1 to 20 or 0 to 20. But we can choose to start somewhere, like maybe start at number 1, stop at 20, and step by 3. We're going to count up 3 at a time instead of 1 at a time. So range, start, stop, and count by step size. We can also do that in a for loop to get numbers. Once again, I'll reset the output thing, and then each pass through this for loop, I'll add whatever I is, pass I into a string, and then add a comma in the space to make them kind of look nice. Same thing we've done in the other ones. And I clicked over quickly, so there's the syntax. Once again, it's a for loop, but we have this collection built into, or a way of creating a collection built into the language that just is all our numbers in order, in sequence. And if you want to walk down, you can just set your start point to like 20, your end point at 1, and then -3 would be your step size to go down. When we run that and see we start at 1 and then just count up by 3s until we get to 20. That's the main loops we have to work with. Any questions about those? I assume no questions, so I'm going to move on to the next thing, which some of you all may not have seen before. I'll do it on this last one. I'm going to make a typo there in the word help. When it's if it's an initial assignment, it'll just create a new variable. But here, it's an assignment operator, which is like a reassignment, which means the variable already needs to exist. So that's going to throw an error, right? If I come up here and run that, we'll see an error message pop up pretty quick. Yeah, a name error. It didn't recognize this thing out at. So we have those error messages. But there are ways to handle this. And this usually doesn't show up in the SDEV 120 class, so some of you all may not have seen this before. Some of you all may have seen it before, but we have ways to check for errors and work around them. Basically, we put in the instructions we want to happen, but if it throws an error, we put in alternative instructions that will run if an error happens. That way the program doesn't just crash. The program keeps running as much as possible. We're going to handle that exception. So everything in Python always gets labeled as an error, but in general for computer science, there's a slight difference between errors and exceptions. Errors are unrecoverable. Error is a complete disaster. There's no recovering from it. An exception is like a little hiccup we can get over. So like an exception is a small leak in a boat. A little bit of water's coming in, not a big deal, something we can handle with a handful of tiles and just move on. It's a boat. Things are going to get wet on a boat. Whereas an error would be like the boat just hit an iceberg. There's no recovering from an error, but exceptions are just small hiccups that we can work around. So we often want to address those, especially in a game, because we don't want our game crashing completely if we can just avoid it. So some of y'all may not have seen this before, some of y'all may have. So in short, our keyword is try. We're going to try to do something. So let me set up a start here. So maybe x equals 12 and y equals 0. I'll start with those numbers because in a game situation, obviously those are going to be based off the stuff happening, not just directly programmed in between that, but maybe we want to divide those two numbers. And that would be a problem, right? Actually, I'll just go ahead and do that. Output equals cast as a string x divided by y. I'll go over here and run this. We can't divide by 0. That's just a rule, a mathematical rule. The whole concept of what number times 0 gives us this other number just doesn't make any sense. So it's something that we can't do. So, but maybe we won't always have, maybe the way our game's set up, we won't always have a 0, but there's a chance there might be a 0 there. In that case, instead of just putting the instruction directly, we can throw in this keyword try. Try to do this instructions. Try to make output equal to x divided by y. And if that doesn't work, we say except, and then we'll say output equals, can't do the division. I think I may have done this already. Notice I used the apostrophe, can't instead of cannot. So we can nest those. I did the string with double quote marks We can use either one in Python. They're interchangeable, completely interchangeable in Python. Some languages, they are not interchangeable, but they are in Python. And if we use double quotes, we can put a single quote mark inside of them. But if we needed a single quote mark there, that would cause problems, right? And vice versa, if we have single quotes on our overall string, we can put a double quote inside them. So if you need a quote mark or some special character, you'll want to use an escape sequence. So backslash is called escape sequence. Escape out of any coding and actually use this specific symbol and then come back into it. So it escapes out of anything that, in this case, the single quotation mark or apostrophe might mean to the Python programming language, so we don't inadvertently run code. So there's a lot of escape sequences. We'll see a few before long. Backslash n is new line. That's an important one. Backslash s is for a space. If you don't want to just concatenate together a space, if you think that looks weird, you can put backslash s. But kind of a small one here. The main thing is exception handling. We're going to try to do this, but if y happens to be a 0, we can't do that division. So if we can't do this instruction, then do this instruction instead. So almost like another branching structure that gives us a way to handle that error. Now we just get the message, can't do the division, but our program didn't crash, our game didn't crash. We can continue playing on and the small glitch didn't hurt anything. That'll be very important in games, because we don't want, there's a lot going on in video games. We don't want them to crash over a small glitch. We want to wait until there's a big problem before the game crashes. We want people to be able to keep playing. So, but if it's a number that we can divide, it does that one first. So that's exception handling. Or looks for any other number. I'll put that in the comments. So any number other than 0, it'll do the division. It's going to try to do that first. But if that doesn't work, then it'll do that instead. So that wasn't really in the prerequisite for in the logic course. So that's probably something new you haven't seen yet. Let's see, what else do I have? Oh, next up is functions. You probably noticed I didn't pause there to ask for questions. Exception handling is kind of an art form. If you haven't seen it before, and even if you have, practice around with it and then see what sort of questions you have. Play with it for a while and see what questions develop, because it is kind of a unique art form. Some people are naturally better at it than others. Some programmers are naturally better at it than other programmers. And also, if you see that in reference material, you'll know what that's referring to. But give that a try if you haven't seen it before, and let me know if you have any questions about it. One that we'll use a lot, starting very soon, is the invocation tool from our 4 constructs needed to solve problems. We need to jump out of our sequence, do some other stuff, and come back to it. In the case of programming languages, that's usually handled through functions. So in Python, use the keyword def for define. We're going to define a function. I'll call the example here my void function. I'm going to pass in a value, but we don't necessarily have to pass in a value. This is going to work. I wanted to show something, but I think it works without it. So here I'm going to assign the output to be, this string was built, in inside a method. I'm going to make some changes because I think this will work the first time. So that's our syntax for a function. Once again, that basic Python syntax of keyword. The stuff specific to our situation, which is giving this a name so that we can ask for this instruction over and over and over again. And inside of the parentheses, if we need some sort of value to work with, we can pass it in. You can also leave that blank or a comma separated value to pass in lots of them. I'll just go ahead and do something with what we passed in there. Okay. Oh. Method output plus equals and output plus equals cast X into a string. So like we saw earlier, building that up slowly, just a string built inside a method and whatever value we passed in, it's trivial, it's just saying that. But that's our syntax. Keyword, our situation, then a colon, and then we indent all the instructions. And then whenever we want that to run, we just ask for it by name. And the way I like to describe it is if we just put a reference name there that we created, that's a variable. That's for holding things. Then up here, a few lines back, we saw with a list, if we have our reference name followed by square brackets, we're accessing things from the list. Oh, and use square brackets. So even if you have like a tuple, like we've been doing with our vectors for the RGB colors, and you just want to access one of them, it's still square brackets to access any sort of list. The list that we can change the things in are the square brackets. So those are different meanings of the square brackets. Even if we use parentheses here, we would still use square brackets to access it. So just a reference name is a variable. That's for holding something. If we add square brackets in and pass in an index, that's for an array or a list, some sort of list of things, a collection of things. So we're asking for, so it's for storing lots of things, I guess is the way to put it. And parentheses are kind of our symbol for doing something instead of storing something. So I'll pass a 5 into that. So just ask for that name that I made up there, and then passed in some number to fill in this parameter X here. So I'll come over here and run this. This didn't show up. That string we just built is not there. And okay, that adjustment did work. And the reason is because of scope. So out here, we're using output all over the place. It has global scope. We have access to it everywhere. But when we built this function, same output here only exists in that function. It's local scope. So if to adjust for local, between local and global scope, we have to use the keyword global and then say what variable we want to use, or variables, just a comma separated list. So global output, X, Y, Z, my number 2, whatever ones we want to use go as a comma separated list after the keyword global. And then when we call this function and it goes into these instructions, it knows to use the output that has global scope spread out over the whole program, not the local one. You can see that it built that string, passed it in, and then that variable output with global scope is now used to store that string that we built up. So that's a void function. Along with void functions, we also have return functions. Once again, I'll pass in a value. That part is optional. We might not need to pass in any values. We might need to pass in 50 values to make something run. Right? Whenever we called those built that were pre-built in the language, there was a little predictive text shows lots of things there. We can also assign default values. So I'm gonna put that there, and then I'll make a choice. So like if x is equal to 3, then I'll say return no value passed in. Else, so one or the other situation, set up a default value, which makes that an optional parameter. Up here, I said there's going to be a value passed in, and there's nothing there. So if we don't pass anything in, it's going to, there's an empty spot that's going to cause a problem when we try to use it. Here, it says expect something to be passed in, but just in case there's not something passed in, make it 3 by default. That way it's not going to cause a problem if there's not something passed in. And then we use our keyword return a plus cast as a string, whatever is in that value was passed in. So that's a return function. So whenever we ask for this one, it's sending us back something. So we will need to put that somewhere. So I'll put it in output down here afterwards. So output equals my return function. And the first, so I'll leave that blank here, and it should go with that default value. Say no value got passed in. But alternatively, I could say 7. And then it'll pass in a 7, and then that will override the 3. Yeah, I always like to point out that word. That's the term for it. Override means to change the default value. It's like the most misused word in Hollywood. I guess writers in Hollywood don't really know what that word means, and they seem to use it all the time to save the day. So next time you see somebody in a movie, say, or TV show or something, say they're going to try overriding something to make it work, and then that saves the day. Picture that character saying, "I'm going to try changing the default value," and it makes that line seem a little bit silly when you hear it in movies. And so that time the default value was overridden, so we got that other option in our if-else statement. Any questions about functions there? I assume the silence means no questions, and hopefully you can still hear me. Can y'all still hear me?
Yeah.
Yeah. Okay. Yeah. No questions is good. So this is our basic syntax, and again, I'm going to send this out. One more thing I want to cover though. A very common thing in games is going to be a high score list, right? And we don't want that high score list to get erased every time we start a new game. Which means we also, along with working in RAM, we need to store some stuff. And our simplest form of storing stuff is sequential files. It is definitely in the shell, the newest shell for SDEV 120. It wasn't in the old shell for SDEV 120, but a lot of people still included it. Has everybody seen sequential files? Well, just to recap anyway, the basic idea is our simplest way to store data is to go put it in a text file. Go write it in a text file, and sequentially, that means basically we're going to put one data point on each line, and we're going to write it, keep track of the order we write it in. That way, when we want that data back, we just read it in the same sequence and we know where it goes. We know which variables went to what line in that file. So basically, it's just writing the text file. So there's a couple different ways to do it. The way I like to use it in Python, I feel like it matches the rest of Python, is when we use our keyword is with. And whenever we do it, we have to write a file. We have to create what's called a file handler. The file handler isn't exactly the file. In a lot of situations and a lot of textbooks and things will refer to a file handler as a file, but they are different. A file handler is the thing that knows where the file is. The file's on the operating system, and that might be on different machines with different operating systems. So the file handler is the thing that knows where the file is. It's the thing that can see our data, and then we can ask it what it sees, basically. So to create a file handler, we use the keyword open. So with open, and then the file we want to open, I'll call it persistent data.txt. I'm going to create a text file called persistent data.txt. I'm going to open it in write mode to begin with. Then we need the keyword as and some sort of name. I'll call it file handler because that's exactly what it is. Generally, when I'm writing my code, I like to name the file handlers to file and from file, just to keep track of which one's which. So we have that basic Python format again. Our keyword, with does show up other places that aren't going to be included today, but our keyword followed by our particular situation, a colon, and then we can indent stuff. And file handler, and then the file handler has some built-in methods that we can ask for, such as mainly at this point read and write. We opened it for write mode, so we can write something to the file. All right, storing data in a sequential file. Then \n for a new line. So I want each data point to go on its own line. So writing a sentence to the file. So file handler dot write, whatever's an output. I guess right now the output is going to have the most recent function. This is stuff we just put on screen. And if you use any of the other methods to access the file handler, you have to close it. But the with method, the nice thing about that is that it will close it for you. So two reasons I like it is it will automatically close a file when we write them or read them. And the second reason is I feel like it fits the basic Python syntax a little bit better. So now that it should write a file for us. But I was talking the whole time I was typing, and I'm sure everybody here is well aware that typos happen when we're just typing. So our output looks the same as it did before, but if I hit Windows E key here on my keyboard to open the File Explorer and go navigate to the folder where this is at, I didn't put any sort of directory path, so it's in the same place. If you want to put it somewhere else or work from it somewhere else, you just want to put the normal directory looking path, the whole path, C drive, slashes, and all the folder names to get to where you want to put it. Then finally slash file name. But if you don't put any of that, just put the file name and it'll put it in the same place. So it created this text file here called persistent data. And the first data point, that string describing this. And then the second point is what's actually in our output variable right now. Close this. So it's stored in data, and then to get it back, we can do the same thing. Use our with keyword. We're going to open something. We're going to have a file handler open something. Well, that same file, persistent data.txt file. Only this time, we're going to open it for read mode. I'll call it file handler again, just since this is a reference thing I'm going to send out in a little while. But typically when I'm writing my code, I like to call them to file and from file. That feels a little bit more organizational. So when we open that file to read, first thing I'm going to do is make our output variable, the thing that prints to the screen, back to a blank string. And then we talked about the for loops earlier. In Python, we actually have for each loops, and not just for lists or arrays or tuples. It's for anything we have. And it will try to divide it up in the natural form for the thing we ask it to. So in this case, if we did a for loop, so we're looking at a text file. So the most natural way to split up a text file is line by line. So we can say for line in file handler. So the file handler is the thing that can see our data. So it's going to see this text file with a bunch of lines in it. And we're just going to say for every line in that file that the file handler can see, we want to do something. I'll just concatenate assignment that line to the thing. The one problem though is I wrote that with line breaks. There's a line break there, plus I'll add a line break in there since I didn't actually write it there the first time, but now there's a line break there. So those files all have line breaks at the end, and that's how we organize stuff in the file. So we need to get rid of that. And whenever we have, it's a text file, so it's going to be read in as strings. And you may have heard this before. A string is always an array. In all of our languages, a string is an array of characters. So we can use those square brackets, like we said, to ask for which characters we want. And Python allows a through syntax. We can read from 0 and then a colon for through index -1. Because we know the very last character in that line is the line feed character, the line break. And we don't want that. We're going to start at the beginning and then a colon for through. In Python, it allows negative indexing, so we can go backwards in our array too. And if we go back 1, then that's going to go back to before the line feed every time. And that'll read the stuff back in. So whenever we have it, we just use the write command a bunch of times to write all our data in a certain order into a text file. And then when we read it, we can just say use that for each thing. So for each line in that text file that the file handler can see, so in this case, concatenate it to our assignment operator. In your actual game situations, you're probably going to have a selection structure there. See, like, if it's to check and see what it is, make sure it goes back in the right place, or different ways to work through it. But this will read the file back in, read the data from the file back in. You just want to be consistent. So maybe you have everything about your character or an NPC or one of the mobs in the game in an array, like I said earlier, or a list, like I said earlier. Then you're going to loop in the right option, the right file handler. You're just going to loop through that list and write each one of the elements from that list onto its own line in the file. Then when you read them back, you just loop through them again and read them back into the same spot. And that's how you save and retrieve data. Anybody have any questions about that? I go run this, you can see there's the data that was put in the file. Storing the sequential file was saved before it was actually put into that variable. And that way we can keep data around from run to run, which is very important in games, right? At the very minimum, we might want a high score list somewhere, or be able to pause and restart the game, or shut the computer down and come back to a game if it's going to be a long one or something. Different situations. So that took an hour and 10 minutes. That's what I wanted to cover with Python syntax. That is our basic syntax for Python. And essentially, that's the part that the interpreter knows. A programming language, the interpreter or compiler knows these basic tools, knows what defining a function, how to define a function, and how to do the exception handling, how to do a while loop, and how to do an if loop, and variables and lists and things. So the interpreter knows that. So we start with that, and then the entire programming language is just things built up from those pieces. Oh, that's not where I was going. So if I come back over to File Explorer, like here on my computer, if I go to the C drive and into the users folder, where's users? There it is. And then in Chris, then somewhere down here, there's a folder called App Data, which is by default is hidden. So you have to turn on hidden folders if you want to see it. And then App Data, there's something called Local. And then in Local, there's a folder called Programs. And then in Programs, there's a folder called Python. And in that folder, this is where the programming language was installed. A quick way to find it, if you have Python installed on your computer, you would have got idle installed there as well. There's Python. The basic idle editor for working with Python would have come in there. And if you go to File and create a new file here, and then without changing it, if you just go to Save, it's going to try to save where the language is installed. If you do that, you can just highlight the address and Control-C, copy it, and then bring that over to your File Explorer and paste that in to get to where the language is installed. So once we have those basic tools, the people that built the language, what they really did is here in this folder called lib, is a whole bunch of Python scripts. Lots and lots and lots of Python scripts. And when we do pip install, it adds them to these. It adds them to this folder called site packages. So like, thought it was going to be in this folder, its own folder. Ah, there it is. So in here, in site packages, there's this folder called Pygame, which is made up of a whole bunch of Python scripts. I'm just going to open one at random here called camera, edit that with Notepad++, and you'll see it's these tools we just looked at, defining a function, in particular, how to initialize a camera. And then that has that global keyword, some libraries to import, an if, elif, else structure, some more if things, more ifs, lots and lots of ifs, and some other functions, what to do when quitting, more functions. This is the camera object. We're going to talk about that apparently Wednesday. When I put the schedule together, I was thinking we might get that today, but we'll see it. You'll see it's a whole bunch more functions being defined. So we take those tools and then build up a language, and that's what the entire programming language is. And when we installed Pygame, that's what that is. It's just more things. If I come up a level, one I always point at is the calendar library. This is in the core language. Whoops. I didn't mean to actually run that script. I edit that. See, there's some import stuff, square brackets on a comma separated list. So that's an array or list, some assignments, classes, go past the classes, and then down here we get functions. Somebody defined a function called isLeap that takes in a year, and if what they got in mod 4 is equal to 0, and it's not a century, so if we divide that year by 100 and do not get 0, unless it's also divisible by 400, because every fourth century does count. But if those conditions are met on whatever year they gave us, then we'll return either true or false to say that is a leap year. So we take those basic tools, and that's what the programming language is built up from. And once again, it's huge, lots of things to look at. Always look at official documentation first. But like I said earlier, the people that are really good at writing programming languages may not always be so great at writing English sentences. So sometimes the official documentation is hard to read. I'll just put something in Google here. I'll say that one we were just looking at is on my mind. Leap year in Python. I know that's in there. So see some tutorials, Python guides. That might be a good one. Stack Overflow might be good. If you go to the things like forum sites like Stack Overflow, make sure you check the date, because programming languages do change. So some of the older dates might not be right on, might not exactly be up to date. I'll put it exactly, isLeap in Python. Maybe that'll get the, so you see what I just typed in there didn't even get to the official thing. It just went to tutorials. W3, they have good reference material, but again, it's generally like a tutorial. There it is. So somewhere you should see docs.python.org. So always check official documentation first, because that's the one that will stay up to date as it changes. So you want to get used to how the people that wrote the documentation for the language you want to work in wrote things. You may have to look at this and be like, is an integer specifying the first day of the week? That doesn't make any sense. Go back and check the tutorial. And after you do that 2 or 3 times, then you'll get used to the way these people put their stuff together. Because official documentation is also usually generated from comments put in the code. They didn't sit down and write this file. They put comments in their code and then ran it through a generator that turned those comments into a web page. So sometimes they're a little cryptic and hard to read, and it might take a minute to get used to how they put the documentation together. But just remember, check official documentation first, then look at a tutorial and make sense of that with official documentation. And usually after 2 or 3 passes of that, you'll be able to make sense of what they put in the official documentation. So there's still some stuff that needs looked up. We're very limited on class time, and I want to make sure there's plenty of time to practice. So my lab suggestion for today, I said earlier, is just some try trivial examples of rectangles, circles, and text to put together user interfaces. Maybe not necessarily a particular game, right? Set up a variable called hit points, and then manually change that on each run of the program to make sure the pictures displaying that information to the player are working like you want them to. Because that's something we're going to want to do in every game we write. So practice that, and then as soon as we start putting games together, you'll already know how to throw a HUD on that game and give the user, the player, the important information. Anybody have any questions about this? Okay, I assume the silence means no questions. So
I have a question.
Yes.
Where do you download the software to use for it?
That was shown in the first week. I will show you after class. If that's okay, Zach, if you hang out for a minute.
Okay, thank you.
Yeah, and otherwise, that was it for today. That gives us 55 minutes left on our scheduled time. I will keep my video set up here until 4:50. So I'm going to end the video call. That way the recording will render down and be available on Ivy Learn very, very shortly. But text messages and Ivy Learn messages make noise on my phone, and I'll keep my video set up here so I can jump back on the Zoom call in a couple seconds notice if you have questions. So the rest of our scheduled time here is to actively apply these concepts to learn these skills and get good at them. Otherwise, I will see you all on Wednesday, and we'll talk about object-oriented programming and perhaps get into collisions and timers, which is the main way we control what's happening in the game. Everybody have a great day. Let me know if you have any questions.
Have a good day.
Great. Yep. You have a good
Thank you.
one,
Have a good day.
Chris.
See ya.